Hey, what's going on, guys? Let's do this problem right here. Let's find out whether this series converges or diverges using ratio test. So here how we do that test. Limit, we take the limit n approaches to infinity, and we take an plus 1 over an and find out whether this is less than 1 or equal to 1 or greater than 1. If it's less than 1, it converges. Equal to 1, no conclusion. If it's greater than 1, diverges. So let's do this one to this one. Here this is going to be limit n approaches infinity. An plus 1 mean we add 1 to anywhere we have n. So here we have 2 power n. So we are going to have 2 power n plus 1. And we have n factorial. So this is going to become n plus 1 factorial. So this is what an plus 1 mean, right? And then we divide this one by the original function. Original function is 2 power n over n factorial. If you divide this one, that is same as multiplying this one with reciprocal of this one. If you divide it, this will flip and go to the top, right? So instead of doing that, we can directly write this is n factorial over 2 over n. If you divide, you will get the same result. Now what we can do, we can cancel something. So if you notice that 2 power n plus 1 is same as 2 power n times 2 power 1, right? So we can cancel this 2 power n and 2 power n. We have 2 power 1 that is remaining. And n factorial and n plus factorial, n plus 1 factorial. You can think about 6 factorial and 6 plus 1 factorial. So if it's 6 factorial, 6 factorial, that's going to be 6 times 5 times 4 times 3 times 2 times 1, right? And if it's 6 plus 1 factorial, that means 7 factorial. This is going to become 7 times 6 times 5 times 4 times 3 times 2 times 1. And you can see everything except n plus 1 is going to be cancelled. For example, let's show this one right here. So we have n factorial right here, and then we have n plus 1 factorial. This one expands like n times n minus 1 times n minus 2 times, and it goes until, let's say this value is bigger than 1 to 3. So this is going to end up like 2, 1 and finish. And n plus 1 is going to go like n plus 1. Then we reduce one value, so that's going to be n. Then n minus 1. Then n minus 2, and this is also going to end up like 2, 1. And you can see this value cancels with this one. So only thing that's left is n plus 1. So that's what going to happen right here. So this will cancel with this one. So we only have n plus 1 left. And finally we end up with limit n approaches infinity 2 over n plus 1. And you can see this is going to be 2 over infinity if you apply the limit, if you apply the infinity for n value. So this is going to be 2 over infinity, that's equal to 0. And as we discussed before, if it's less than 1, this is convergent. So this is the convergent series because this is less than 1. So we can conclude this is a convergent series. And also this is absolutely convergent series. So when we take the ratio test and if it's passed, that is, if you get convergent result, that's absolutely convergent. So that's how we do the ratio test for series. I hope you guys find this video helpful. See you next time.